Let me introduce our second speaker for this panel. This is Maciej Szpindler, the Polish representative in the LUMI User Support team. And Maciej will talk briefly about the user environment and about the support team in LUMI. So Maciej, can you jump in?
So I will try to give you an overview how or what you can expect from the perspective of the user. So what is the expected user experience? But I would like to stress that I will focus now on the current, let's say, services that is already available. And I will try to introduce a little bit what is expected in future phases. So let's begin with a short overview of how the overall support is organized. So as a, let's say, a future LUMI user, you will interact with either a LUMI user support team, or also you will possibly interact with local support. And both of these, let's say, teams will help you to use the system in best possible way. There are also two different, let's say, groups in the loop. The COE, which is the Joint Competence Center with HPE, which also supports the users projects using the system, and the teams at hosting entity, which is a CSC center in Finland. They are providing system maintenance and all the hosting services. So as for LUMI's user support team, it is a distributed team of experts. And as you can see, we have usually one expert per country of the consortium. There are some exceptions where there are two experts, and each of us will provide expertise and will somehow coordinate support with either our team or the local support team, which will help you with get access and get your accounts on the system, and also with some other issues. And what LUMI user support team offers? First, it's a help desk service. So you can the place where you can issue any problem you have with a system, and then all the support will be coordinated. We have already web pages with documentation and also frequently asked questions. We have prepared computing environments, which I will describe later on the system. We do code enabling, and we will prepare a set of supported applications which will be optimized for this architecture or architectures, as it has different partitions with different architectures. And also, maybe most important, we provide user trainings. So as a user, what you can expect, partly it is already described by Andreas in the previous talk. So with the operating system, you should expect, let's say, experience as the same experience as with a different Linux systems. It's a little bit specific, but you should not see it or experience at any moment. For now, the basic or the most, let's say, first protocol or way of access is the SSH protocol, which you probably know from the different system. And future extensions will consist of web interface, which will provide remote desktop to run either terminal jobs or jobs with graphical user interfaces, as well as a cloud interface, which will be based on Kubernetes service. But it's a future, let's say, a future feature. For managing resources, you will use Slurm to submit your jobs, at least for computing partitions. To use applications, you will need to use module environment, which is, I think, widely known from many different systems. And also there will be central repository of applications, which will be supported in a sense that any problem with this central set of application, you can you can consult with a help desk service. For applications that are not already available on the system, preferred way of self-building of applications is via EasyBuild, which is quite a powerful tool for maintaining, building and maintaining software codes on the HPC machines. And as an alternative, you can also use Spec, which is similar tool. As already said, for the HPC containers, Singularity is fully supported. Basically, you can run container, and for most of cases, you can seamlessly import Docker container from, for instance, Docker Hub, and convert it on the fly and run on the compute node. For the containers, we will provide a set of basic, let's say, building blocks. I mean, containers that will be a kind of certified by us, and also bring your own container policy will be supported, but in a limited way, because you should not expect that each container will be compatible with the system. As for programming environment, it is provided by the vendor. I mean, the first choice is a Cray programming environment, which I will describe a little bit in a little bit more detail. So what it consists of? Most important elements, as from the user perspective, is the compiler choice, and currently supported is a Cray compiler, which is basically optimized version of Clang compiler, so LLVM based, GCC compilers, so GNU compiler collection, and also compilers from AMD. These three choices are now possible for compilers. For GPU environment, two choices I would say are recommended. One is HEAP, which is, let's say, a way to program very, very similarly to CUDA, or do the seamless transition from CUDA code to code that will run on AMD GPUs. Another approach is to use SYCL, which is, let's say, a modern C++ extension to support multiple GPU architectures. For high-level GPU programming, OpenMP is the, let's say, first recommended choice. And as for libraries, you can expect Cray-MPIC on the machine, which is the primary library for multi-process applications. So basically, MPI codes should run using MPI using Cray-MPIC. Also, numerical libraries from Cray, which basically are packed with a libsci package, and also libraries from AMD that are optimized for AMD processors. So regarding a future GPU partition, let's say the most easy way to translate from already implemented GPU code is to do translation from CUDA to heap, which is often called heapification. There are translators that simply, let's say, generates heap code from CUDA code, and the overall process should be very easy. And for let's say porting or migration from different systems, different architectures, and also for extending current code to support AMD GPUs, GPU offloading, which is, let's say, a modern part of OpenMP, is recommended as a first choice. As for machine learning frameworks, you should expect at least the most popular already with a support for AMD GPUs. So you can either expect them available on a system or use them from the container that is with AMD support. You can also use portable frameworks, which here are, for example, listed Cocos, Raya, and Alpaca, and possibly others. And for these frameworks, you should expect fast and increasing support for AMD GPUs. For storage environment, it's now, let's say, very preliminary stage, and for very first access periods, you should expect just let's say a regular or a common experience from the other HPC systems. So you can use a Lustre file system for storing your data, let's say as a home directory, and the more performant, faster storage as a Scratch file system that is using flash storage. And these resources are, for the moment, quite limited on the compute nodes. And these, as it was presented by the in the HPE presentation, there will be further extensions of storage services, and most importantly for object storage and fast flash storage partitions. As for applications, there will be, let's say, a separate sets of applications for either CPU partition, so LUMI C, and possibly different set of applications for GPU partitions that we will provide. And this will be basically, as for CPU only codes, these will be basically optimized for AMD Zen architecture, which represents, which the nodes represents. And here also multi-threading is recommended, while this compute nodes, I mean LUMI C partition, will have 128 CPU cores, which is quite a lot for now. And for the CPU partition, you should expect most of the, let's say, codes that are not already installed, that they are just run out of the box, so you just simply can compile and run them. For the GPU partition, we will provide, I mean LUMI User Support Team, will provide a set of GPU-enabled applications. As for now, you can also, let's say, try it in home using a set of already published AMD containers, which this service, I believe, have a set of AMD codes already. And we've already enabled support for AMD GPUs. For other codes that are not, let's say, GPU enabled, considerable effort is required to enable or port them to run on the GPU partition. There will be also a cloud partition, but it's not, let's say, available at the moment. As for trainings, I would like to advertise 2 trainings that are already available on the for the registration. So you can choose either both of them or one of them if you are already, let's say, advanced in OpenMP, which is, as I said, very first choice to program the LUMI environment. And both of them are on the beginning of November. You can just go to the LUMI Supercomputer UE portal, and then you will find the links to register to the events. And there will be, let's say, a further extension of the courses that will be announced soon. That will, for example, address containers, Python codes, and the frameworks that are using GPUs. Expect also GPU workshops and hackathons that will help a broader audience to get familiar with the AMD GPU architecture. Now a bit of, let's say, specific for Poland information. So probably you would like to know how to apply for access. So you have 2 paths to select. First is, let's say, a national path that will use a Polish allocation share, and it's a process that was designed with an acceptance of the Ministry of Science, of Education and Science. And here you have 2 choices. You can apply either for regular access that will be posted with whole year calls, and then applications will go through the review process, and we plan to announce this calls in March and September each year. For let's say test or preparatory access, there will be continuous call. And for both of these access modes, you can apply via Pelgrid portal, and you can submit your proposal there. The second path or alternative path of access, you can go through the EuroHPC JU access path, which will use the resource share allocated to EuroHPC JU, and these will be, because it's not open yet, this will be, let's say, supported via Praise portal. You can see link here, but it's the call is not yet open. And similarly, as for national process, this will also go through the review process, which is as well organized by Praise. Praise is a project and also a consortium for partnership for advanced computing in Europe. And you can find it on their portal, which is praise-ri.eu. You can find all these links in the chat. Thank you, Camille. And the last, let's say, a little bit details on the pilot calls. As for this event, obviously, we are meeting because of the phase 1 or first phase of the pilot access is starting now, namely today. And this is already closed, and 2 projects were selected, and you were listening to the PIs of this project presenting their science and their plans. And this access lasts for 28 days or 1 month, and it's basically unlimited access. So you can use as many resources as you can in this phase from the CPU partition of the system. The second phase, which will be basically about GPU partition, should be announced, the call for the project should be announced in October. And this is again allocation for 2 projects from each consortium member, so for Poland as well. And again, it's 1 month of access, and you can use as many resources as you can. But here, some, let's say, proof of your code readiness will be required. So we don't need to, we don't want to, let's say, allocate resources for projects that are not able to actually use GPU computing power. And all these pilot calls are coordinated by Cifronet. And the second slide on access, as you already have your, let's say, project selected, how it would go. So how you will actually access the system. This is quite, let's say, interesting construction, because you will use federated authorization and the identification, and going through the service, federated service, you will be then directed to the PearlGrid portal, and using only your PearlGrid credentials, you will be able to register in the whole system, and then your actual account on LUMI will be created without any, let's say, bureaucracy or your intervention. And likely there will be authorization, let's say, and authorization based on SSH keys, so no any passwords to log in. And the last slide from me is about possible ways of or approaches for extended support. So let's say, frankly speaking, it's for the cases I have my code, but I need some help to enable it to run on the system. So for now, there are two possibilities considered. First is the, let's say, level 3 support, which will be for some extent provided by local centers. For instance, maybe also EuroCC Competence Center can help somehow, and I hope Marek may mention it in the next talk. So basically, you may receive some support from your local center, and the other approach is coordinated by the LUMI User Support team, and it's a kind of a code readiness call. So jointly with experts from the HPE, we can provide a project that will help to enable code to run on LUMI. And the details will be announced later. I mean, for this code readiness, or code enabling calls. And how you can communicate with the LUMI or LUMI User Support team. You have here support web pages, newsletter you can subscribe to, frequently asked questions, help desk where you can, let's say, issue any problem. And for registered users, you can also use instant messaging chat to get, let's say, a fast response from the experts. Okay, that's all from me. Thank you very much.
Thank you very much, Maciej. We are now open for questions. So if there are any, just please go ahead. In the meantime, I can start maybe with asking about, which codes do you think, based on your experience and your knowledge of the Polish HPC community, which codes which are common in Poland and which are already used on our systems might be good candidates for the GPU pilot access and might be good candidates for the production applications actually using the AMD GPUs?
Right, so it's probably the question each of one asks. For the moment, I think the molecular dynamic codes are very good candidates. So to be precise, GROMACS is already enabled, and also LAMPS has even two, let's say, paths of support. As well, you can expect CP2K to run on the system, and we have some preliminary experiments with VASP, which is, I believe, very popular in Poland as well. But it's here obviously is also let's say a matter of license. For other codes, as I mentioned, you can already expect most, let's say, popular machine learning frameworks to be enabled and available on the system. And that's let's say the first candidates I can now name.
Okay, thank you. And we have some questions from the attendees. Does the OpenMP with some extensions or HIP will allow to exchange data between GPUs through Slingshot with GPUs in other nodes, or is some hybrid with MPI needed?
basically answer is yes. Obviously with MPI, but not, you are not, let's say, restricted only to MPI. You can either use RCCL, which is the, let's say, the one-to-one alternative to the similar library within a CUDA ecosystem. So basically, it's for direct communication with, between GPUs that are in remote nodes. But it's now more, let's say, concentrated on the machine learning use, but you can also use it directly from your code. And that's also a different possibility, but I'm not quite sure if it's mature enough. I mean, the OpenMP offload can also support remote offloading. So then you don't need any MPI at all.
Okay, thank you. Another question is why AMD GPUs are used in LUMI G instead of NVIDIA? Support for AMD GPU, in particular ROC and HIP, is much weaker than for NVIDIA in molecular modeling software. GROMACS, for example, supports only OpenCL for AMD GPUs.
So I think I could not answer to this question. So I don't know, let's say, the background of this choice. Maybe Marek can do some comment on that.
Yeah, so the system was procured through a public procurement coordinated by the EuroHPC JU. One of the big points in EuroHPC in Europe was also to provide an infrastructure which will be heterogeneous, so that we all don't put all of the eggs in one basket. And in particular for LUMI, if you compare the size of the system, I mean the performance of the system, with some other pre-exascale systems which are based on NVIDIA, or which were supposed to be based on NVIDIA, it seems that there is an obvious benefit in terms of performance if you decide to go with AMD. And the difference is huge. It's between 50 to 80% more compute power for the same budget, both on the investment side and on the TCO side. So obviously this involves some risks, and this involves some additional work which needs to be done to either modify the applications, enable the applications to utilize AMD GPUs. But on the other side, if you look at what's happening in the HPC technology currently, and with some other vendors also hoping to join the race in GPUs, it shows that a lot of work needs to be done in GPU-enabled codes anyway. Even if you consider NVIDIA-only codes, they will also need to be modified to utilize the future architectures in the next few years. So I don't really think that this is something which will be a big obstacle. It might delay a bit the adoption of GPUs in LUMI, but I don't think that this is something which won't be overcome within the next few months. So I'm pretty sure that with such codes as GROMACS or CP2K enabled, as Maciej said before, we will be able to easily utilize the system with existing software, not even mentioning users code, which can be also hipified and enabled.
So I can see question directly in chat. Will be there development possibilities to achieve the code readiness for the GPU contest? I can say that from, let's say, LUMI, you can expect some hackathons that will be possibility to let's say have your hands on this architecture, but it's not in the same, let's say, time frame, as the pilot call is rather expected to give possibility to the groups that already have their code enabled to experiment with the system. But for the further, let's say, perspective, maybe we can, I don't know if we will manage to do something on national level to provide some, let's say, experience with AMD architecture. Possibly, yes.
Yeah, so this is something which we would like to do within the EuroCC, which I will mention in a few moments. But in general, I would also like to emphasize the fact that Poland is the only country which is running contests, which is running open calls for the pilot access. All the other consortium members have just arbitrarily chosen some of the codes which they have already worked with and decided that they are going to be used as pilot cases for LUMI. We have decided to go a bit the other way, so to engage the scientific community to also allow us to identify the groups which are good candidates for the future but require some work in advance. So yeah, answering your question, yeah, we definitely are thinking about such activities. And what Maciej mentioned before, we are also in contact with AMD about getting some dedicated infrastructure for the use of code porting and enabling. So this is something which should be clear within the next few weeks. As you have probably seen, the product, the GPU which is used in LUMI is still not public, and this is a bit of an obstacle. It is actually a bit delayed, so the AMD GPU is a bit delayed, mostly because of the current semiconductor issues around the world. But I'm pretty sure that once the GPU will go public, and this will happen in November, it will be easier for us to provide wider access to this technology.
Right. So is CUDA code considered to be code readiness? I would say that it's the closest as you can have at the moment, but because I don't expect anyone to have already heap code. So for most cases, it's a matter of very, very basic translation, and you can easily test still on NVIDIA platform whether your heap code is compiling and it's working. So it's quite easy to get the readiness in this case. Further questions I will answer quickly. What about software like MKL? So I can imagine that the real question is whether Intel tools will be available on the system. And that's not entirely decided at the moment, but the libraries as a MKL, for instance, will be available for sure, as they have now limited support for Zen architecture, but I think you can expect to have it extended in the future. So it's reasonable to have it. What about Julia? As far as I know, Julia have some experimental support for AMD GPUs. It's not, let's say, evaluated yet on the system, but for, let's say, pure CPU cases, I think you can consider even just running Julia out from container. It should just run fine. So it should just run. Okay.
Okay, so that were all the questions for now. We will have some Q&A sessions after my presentation. So if you still have some questions, just please wait a few more minutes and we will be able to take them in the combined Q&A in a few moments.